we should be live now. Welcome to Fun with Cars live stream. I have a very special guest that I want to introduce to you right at this moment. Lake Speed Jr., I'm bringing him in. Welcome aboard.
Hey, man, how you doing? This is awesome.
Yeah, doing very good. Now, my understanding is you hail from North Carolina. Is that correct?
That's where I live currently. I'm actually from Mississippi. My dad was a NASCAR driver, so when in 1985 he decided he was going to give the NASCAR thing the full time. Up to then, they really only raced like partial schedules, and so he moved up here in '85, and we've been ever since.
That is awesome. There is a lot to talk to on that subject, and I'd like to touch base back to that. Can you give the viewers a brief history of your career, because it spans through NASCAR, but you have a very extensive knowledge of motor oils, lubricants, the additive packages, and that is specifically how this topic this week came to be, and your invite onto the show because we have something special to talk about.
Absolutely. So as a son of a NASCAR driver and all that, I grew up in racing, and that actually led me to working for Joe Gibbs Racing. I just grew up in the NASCAR thing, and Joe Gibbs, in my opinion, they're the top of the NASCAR heap. And no against Hendrick, they have a better record than Gibbs, but the coach is. I love football, right? I'm a college football guy, and I've always loved football, and so coach is the best. And so to get to work for him was fantastic. And while I was there, I got to be part of the Joe Gibbs oil program. I was actually the very first employee of that program, and we were very fortunate to work with a company called Lubrizol. So everyone watching that has a car, right? Then you probably have a favorite brand of oil, maybe a preference in terms of brand of fuel, something like that. What most people don't know is that with all the brands of oil, all the brands of fuel, all throughout the world, there's only 4 companies that actually make the additives, who make the chemicals that go in to the fuels and the oils: Lubrizol, Afton, Ornite, Infinium. So we were very fortunate to be partners with Lubrizol doing this program, and that's what got me introduced into the science of tribology, which is the study of friction, wear, and lubrication. To me, it's the coolest science ever because it's multidisciplinary. It's a little bit of chemistry, it's a little bit of mechanical engineering, it's a little bit of physics. It's all these different things all happening at the same time. And as someone that really loves engines, I mean, tribology and engines just go hand in hand. I mean, it's like there wouldn't be the science of tribology if it wasn't for engines and trying to figure out how to make engines and mechanical things more efficient and have better durability. That's what kind of gave birth to the science of tribology. So I'm very proud to be a tribologist. There we go. Get my
this is my proud t-shirt. This is my I wonder if I get 3 wishes at my oil that comes out.
There we go.
So the one question I had, when you got introduced to the Joe Gibbs racing team, right? Mm-hmm. The idea is to take their cars to the front. So they're studying the very finite to get to the tippy top of the ice, tippy top of the mountain, so to speak, in terms of speed. So lubrication, and I did watch a bunch of your videos leading up to this, so I gained some knowledge because my knowledge is in the dealership world, auto repair, that side of things. So all of my training in motor oils and oil additives comes from the manufacturer side and from the limited amount knowledge that I have on that side based on some of the information that I gleaned from watching your videos, which I do want to offer up to everyone in chat and watching this stream. Please go subscribe to his channel. There is so much information there. You will not miss out. It's very interesting. And I did clip a short piece of one of your videos when you were testing a lower weight oil. I think it was 2050 versus a heavier weight oil, 2050 versus a lightweight oil, and you took oil samples every step of the way. And I don't know about you, but the engine pull sound of the engine on the dyno, when you hear that, it's, I don't know, it's better than music to me. I don't know if you feel the same way,
an
but
engine when it's running right, yeah, it's
yeah,
like a great symphony. It's like, I think even Beethoven, I think, would have appreciated, you know, a V16 at 16,000 RPM back in the day in Formula One. But that's awesome. That's what music sounds like. But you know,
that I
it's
never got to
interesting.
hear.
Mentioning Joe Gibbs Racing, and the first thought would be, well, okay, man, you're right there at the bleeding edge trying to find the last little bit of power. Okay, we ended up there. That's not where we started.
Okay, that's a good topic then. Tell us about how you got there. What were the steps? What did you find, and where did it lead?
So this is going to dovetail right perfectly with, I think, the reason why we're even having this conversation is that this whole idea of flat Tappet camshafts and modern oils. So real quick backstory, you know, from 1992, it was the beginning of Joe Gibbs Racing, all the way through 1998. Shell was one of the sponsors at Joe Gibbs Racing. And so they gave us this oil called their Motorsports Blend oil, which you can't buy, right? There was no part number on it. You couldn't buy it. Basically, if Shell Corporate sponsored you, they gave you this stuff, and we used it, and we didn't have any issues. Of course, back then, NASCAR was a flat Tappet camshaft deal. So everything's fine. We get through to 1998, and Shell decided they weren't going to be in NASCAR anymore. They leave. So in 1999, here we are with Home Depot stepping in as a sponsor with Tony Stewart, and here we go. And of course, Home Depot now they sell oil now, but they don't make oil, right? And so they didn't have any Motorsports Blend oil. So we're just going back to the parts store and buying oil like we used to know that. Like, I remember from my dad's race team going to the Kmart in Port Orange, Florida, and buying every quart of Mobil 1 they had on the shelf, 5W30 Mobil 1, right off the Kmart shelf, poured it in the engine, and went and finished in the top 10 of the Daytona 500.
Wow.
I remember doing that, right? And I remember at that time, this was 1998, 97, like that. In my mind, I'm like, this is the best oil in the whole world. I will never use anything other than Mobil 1 because I just put this in a 500 plus horsepower race engine that ran 500 miles at wide open throttle, and everything's fine. What could be a better test?
I don't think I could think of one, but
Right.
I'm sure you've tested something even more extreme now that you're doing what you do.
So here's the thing. So I said that was, the late 90s. Within a couple of years, literally, like I think 2 years later, the guys at Gibbs, they're doing the same thing we were doing. We weren't doing anything special or secret. They're losing 1 in 10 new engines on the dyno. Now, remember, we're building 3 to 5 engines a week. That means like every other week you're blowing up a motor on the dyno. And every single one of them was a flat Tappet camshaft failure. So we're pulling our hair out. We're like, what the hell is going on? This doesn't make any sense. We can't figure it out. Fortunately, we were a GM team at the time. GM has a program called Key Partners. So all the GM race teams would all meet together on a regular basis to discuss durability issues. No one had to give away any speed secrets, but the old adage to finish first you must finish.
That's a good start.
GM was big on that, right? Listen, everybody gets this together. If someone's having a problem durability wise, if someone else knows the solution, you got to tell them. So we showed up at one of the meetings. We're telling the story, and the guys from Richard Childress Racing said, "Oh, you got to call Lubrizol." We're like, what? Who? What? And they're like, "Oh, yeah, you got to call Lubrizol. We've already been down this road. They fixed the problem." We're like, okay, we didn't even know Lubrizol existed. They gave us a contact. We call them up. Yep. They say, all right, we know what the problem is. at the time, all we really heard was this word zinc. We were like, oh, okay, just do what you need to do. So their chemists came in, they studied the stuff, they gave us some oils, that had a higher level of zinc in it, and boom, we're off and set. But here's the thing, right? Pretty much everything I've said, people who are watching this, who are familiar with this, are going, yep, this is exactly what I know. This is why I put zinc additive in my oil. Wrong. That's the wrong answer.
Right. You don't, that's my training and experience was, if you went with a oil, whatever brand, whatever it was, you didn't want to mix and match, because of the oil additive packages could affect the lubrication, the wear qualities, the boiling point, a whole bunch, or flash point. I'm probably speaking incorrectly.
The thing is, every one of those additives is trying to compete, right? And the issue, which we didn't hear back in the day, but we came to learn, was that it wasn't just the reduction in zinc, because the zinc levels had changed, and that's a fact, right? I mean, I'm not denying anything about the change in the levels of zinc in the oil. But what caused the camshafts to fail was a twofold process. Not only did the zinc levels go down, what also happened was the detergent levels went up. And it's the zinc versus detergent, which is the key.
Was the
That's
cancellation.
what caused the problem.
Okay.
Right? The detergent, the calcium levels had gone so high, and the zinc levels were low enough that for our kind of camshafts, for what we were doing for a race engine, now the zinc couldn't do its job well enough because there was too much detergent competing against it based on the demand created by the high lift camshaft. So what they did for us was they actually made an oil with more zinc, but less detergent. So we could meet the needs of the application. Problem solved.
Now, there is a modern version of the zinc solution, is there not? It's a 4-letter term that stands for something, probably a much bigger word than I can pronounce. I thought that zinc was kind of replaced by an additive, probably from one of the additive manufacturers that you refer to. Can you tell us about that a little bit?
Well, I watched the video you did with your Oldsmobile engine, right? And saw the thing about everybody crazy about. Let's stay on this track, right? Because I think I don't want to get too far off in left field, because I think we can do a really good public service here by helping people understand the real problem, and to understand that there is a solution, that the situation today is different than it was 20 years ago.
Okay. See,
and I can tell you why. We'll walk through it, and we can do it in the time we have, because I don't have a ton of time today. But we can do that. So
okay,
the solution was high zinc, low detergent. Change that balance. Problem solved. Everything's good. Well, as time goes on, we get to 2004, 2005, and the zinc levels in off-the-shelf oils go even lower, and the detergent levels go even higher, so that balance gets even further out of whack. Now it's not just race teams having the problems, it's everybody with classic cars and things like that have flat tappet camshafts in them. And then that's where the zinc additive deal took off, because this was the easy way to fix it. People didn't have to change their brand of oil, because the reality at that time, there weren't high zinc options on the market. Everything that was a higher level of zinc was a racing oil, like we were making at Gibbs, that had a low detergent level, which was not appropriate for street use.
Okay.
The easy analogy for race oil versus call it street car oil is no different than racing tires versus passenger car tires.
Right.
Racing tires are really good on the racetrack. They're
sticky.
Slick, they're sticky, they're awesome. You do not want to drive in the snow with racing tires. They're the worst tire possible, right?
Right. The compound would be great, but there's no sipes to give you traction in snow or rain.
And they won't live very long, right? So
that's correct. They burn right off.
It's not the right design or chemistry. Race oil versus passenger car oil is the same thing, right? So what happened was people figured out that, well, oh, diesel oils have a higher level of zinc. We'll go that direction. Diesel oils also had a higher level of detergent as well, but the fact that they had enough zinc in them, they were thicker and they were a little more shear stable, it was better than the passenger car was at the time. So this is kind of the history. So that kind of gave rise to this whole idea that, one, you can't run synthetic oil with a flat tappet cam. Don't put synthetic oil in an old engine. I mean, there was already that out there already from the very beginning of synthetic oil. And just for a second, we'll touch on that, just so we can address that. So when Mobil 1 and AMSOIL both first came out, they were very different in terms of, they were both synthetics, but synthetics sound like a generic term. It's kind of like saying, what's Italian food? Well, okay, but you've got pasta, you have, pizza, you've got, antipasta, you have, different seafood dishes, you have all kinds of different things under the realm of Italian food. Could
be from Sicily and Italy.
Parm and lasagna are both Italian food, but they're not the same thing.
Right.
So within synthetics, there are different types of synthetics. They're not all the same. So the Mobil 1 way of doing it was using, I don't want to get too technical. They use basically an ultra pure type process. So it's called a group 4, right? For people that really know the stuff, it's a group 4 is what they use to come out with. And then they added some mineral oil to it to be able to get the additives to stay in there, because the ultra pure group 4 is so clean and pure that it doesn't have any solvency, so nothing will stay in it.
And that was not based off of natural gas, like the
no. That's all super new. It's all super new. It is derived from a gas, but not from natural gas.
Okay.
The AMSOIL originally was from an ester. So an ester is a different type of synthetic molecule. Again, it's synthesized, it's built up, but it is more of like a chemical way of reproducing, say, like the best product or best properties of, say, castor bean oil. So like the old bean oils and stuff that people knew worked really good in, say, 2-strokes. They had great lubricity, but they weren't very stable in terms of handling temperature. So the esters were a synthetic way of trying to make something that had a lot of lubricity that could handle heat.
They use ester oils in AC systems, if my knowledge and memory is correct. I believe they're based.
Yes. So and that's a group 5. So between the 4 and the 5, between the Mobil and the AMSOIL, they were very different chemically. What turned out is both of those directions, full ester, full group 4, had two opposite effects on seals.
Yes. Okay. Please touch on that, because I think the old adage, and this is going back from when I was a kid, the Mobil 1, when it came out. I do want to tell a story about my dad at some point, because it's very related to that. But I remember as a kid, when I first started wrenching on cars, we're talking late 80s, early 90s, the talk amongst, guys working on cars was, don't use synthetic oils because it hurts the seals and the car will bleed out. But I think they had to do with the additive package that they used then, and since then they changed. Please correct me.
Base oil. It wasn't the additive package; it was the base oil.
Okay.
So what happened is that, so the seal manufacturers in the 70s and the 80s and the 90s, they had been developing and using the fact that the regular motor oils in the market were solvent refined. The way that they went about purifying the crude oil through the refinery was they would actually put in solvents, and then they would, basically they could kind of boil the solvents off, and the solvents could carry away some of the nasty stuff. Of course, when you do solvent refining, there's always a little bit of residual solvent left over. Well, what we all know as car people, what happens if you put a little bit of, Buna type seal material and solvent? Swells up.
Swells.
So this little bit of residual solvency in the conventional oils made the seals swell. The seal manufacturers counted on that. It was part of their design process.
Oh, okay.
This is the key part, right? This is where we're going to break some myths down here right now.
All right, cool.
When you have the PAO, the group 4, that super pure base oil that was in the Mobil 1, there's no solvency. There's no solvent at all. It made the seals shrink. So when the seals would shrink, they leaked. On the flip side, the AMSOIL, being 100% ester, made them get too soft. It went the other direction. So the seals would actually literally break down. Like if you get a certain kind of plastic or rubber and you get an aggressive enough ester, it will literally melt it.
Oh, yeah, liquefies it basically, and then it wears off.
Yep. So the first 2 synthetic motor oils to hit the market over time had affected seals negatively. Of course, that caused problems. And what happened is both companies changed the formulas.
Do you know roughly the time frame when they did that? Because I do want to tell a Mobil 1 story when you're ready.
I believe both Mobil 1 came out in 1974.
Oh, that was a lot earlier than I thought it did.
And AMSOIL came out in 1972. So AMSOIL was actually first to market with a synthetic. Mobil was the first to market with a PAO synthetic, but they were within 2 years of each other, really close. I think they both made those changes in the early 80s.
Okay.
Because if you put it in a brand new car, that was the whole thing. But they had done all testing. But the problem is they were putting it in brand new engines. And, it's kind of like anyone that's been around car restoration is going to understand what I'm about to say. If you've got an old car that's been sitting around for a long time, especially if it's a car that was used to run on leaded fuel, that the wise thing to do with modern fuel is to replace every fuel line on the car.
Oh, yeah.
Including the fuel cell. What happens if you put modern fuel in that old thing? It's going to crack, break. Yeah. Think the same thing. That if you've been giving your engine a steady diet of old school mineral oil, all the seals, all the plastics, all the elastomers in that engine get used to that. Now you bring in something completely different chemically, and it freaks the hell out. They go, what? It's like, what the hell happened? Right? This is what happened for a couple of decades there, which is why you have people who were true believers. And you have people like, Porsche and Mercedes that were, even GM that were using synthetic Mobil 1 factory fill, and those cars never had a problem. Why? Well, it's because the seals never had that freak out of, oh my God, you just changed your dot. I mean, people who have dogs and cats know what happens if you change their food on them? They freak out.
Yeah.
It's not good. It's the same thing. So that was the early issues with synthetics. So you had this history already where people were a bit leery of synthetics because of how things happened out of the gate. You come around here late 90s, early 2000s, and the zinc levels, detergent levels start changing, and in fact, to have a camshafts, all of a sudden you got people saying, man, don't even think about using synthetic oil in an old engine. it's going to cause problems. Okay. With that,
So
go ahead.
I did want to just touch on, because the topic and the reason for my email to you to come on was related to the topic of the modern synthetic oil in an antique engine. Now that engine is 87 years old. My dad, and it's Tyson dad, hi dad, happy birthday dad. My dad turned 86 this week, right?
Awesome.
He had a brand new 1988 conversion van that he bought, Chevrolet, just standard small block 305. And my dad read at some point about synthetic oils in Mobil 1, and he said, hey, can you change my oil? And I was just learning how to work on cars. He wanted Mobil 1 in it. So I changed the oil then, and he kept on a regular, 3 months, 3,000 mile oil change with Mobil 1 from 88 up until about the year 2000. In the year 2000, it had the condition where it would blow a little bit of smoke if it sat for 4 days. And my dad and my mom, my dad had retired at that point. They were driving around the country. He was worried about having a problem, even though it was a GM service bulletin for putting in umbrella seals to stop the, that smoke situation. Mm-hmm. So put in a brand new Jasper engine, and I took that old engine out, which was still good in my mind. And a buddy of mine had a boat and he wanted to use it for that. But he's like, you think it's good? I said, well, I'll take it apart and see. Took the heads off. Now, the first thing I had to do was take the intake manifold off to change it over to the other engine.
Yeah.
And when I pulled that intake off, I could eat off the oil valley where all the lifters were. I had never seen that. I was used to, when I started working on cars, we had the oil drain bag problem. The oil would grease up and it wouldn't get back to the pan. You'd have to clean all that out to stop a problem. And when I saw that, I'm like, oh my God, there's nothing underneath here. It's clean. Right. And then I pulled the heads off. I could still see the factory hone in all of the cylinders. It was a well taken care of engine, and my dad's not hard on things. But the point was, that made me a firm believer in synthetic oil. Now, it only ate Mobil 1 since essentially, early on when he got it. It was a few months in. And that made me a believer in synthetic oils, and I pretty much run them my entire life, no matter what it is. I would like you to, to tell me that I'm doing something wrong. I don't want to hurt this Oldsmobile engine. There's a special story with it. The Becca, who may be here. Hi, Becca, if you're here. Sorry, everyone in chat. This is important, so I didn't want to go too far off. But that 87-year-old engine, her dad got in 1969. For his 1936 Oldsmobile. Had it on Marketplace. No one wanted it. I reached out to her. I said, hey, I like to save old cars and old things. If you don't find anyone, reach out. We made a deal. I picked it up. And now it's my goal to get it running again. And my buddy, who I've known for 30 years, he saw the short video. I said, here's my next project to see if it'll run. He's like, what are you doing with a 37 Oldsmobile engine? I said, well, I told him the story. Becca's dad passed away 15 years ago. They sold the car. It's been sitting there. It's kind of, got some memories in terms of meaning because of her dad got it, but it hasn't run since 1969. But I was going to try to get it running, post it. He's like, you'll never believe this. My uncle in 1962, his engine seized on his 1936 Oldsmobile, and that car is sitting 100 feet from me. I said, well, this is your engine if it runs. So now we're on the test and proving. And then the reason for the email, people were flipping out when they saw me for the test on the engine stand pour in synthetic oil. And maybe I'm making a grave mistake. And I trust what you say. I was a little upset because my experience with synthetic oil has been nothing but good. But I trust an expert. You study this stuff. Tell me, is it a bad idea? Is it going to completely disintegrate? Assuming that my buddy's uncle, who's 83 years old, gets to see his car run again and he gets to drive it. I'm sure it's not going to see more than 1,000 miles. And I did not put in hardened seats. I only cut the soft seats that, unleaded oil. What do you think?
So more than likely, if it's a 36 engine and the seals have never been replaced, it is more than likely a rope seal, and it will leak with synthetic oil.
Okay.
So that it's probably not the best option for the seals because of that. If the seals are replaced and you can put modern seal materials in there, then synthetic oil is the way to go. And then I'm saying that from the perspective of a guy that worked for Joe Gibbs Racing, and we were the first company to come out with a synthetic oil specifically for antique cars and hot
Yeah,
rods.
I actually want to show the items related to that, because you talked about the oil that you guys developed for that, and you featured it on one of your videos, and I saw it. Explain how it came to be and what the methodology behind designing an oil for something like this engine.
So knowing the issues, right? We have to address seal. So we actually put seal conditioners in the oil to make sure that even an older style seal, not rope seals, but older elastomer type seals, we could make sure that they didn't dry up. So we used, a type of synthetic oil. It's called a group 3. So it's basically a highly processed mineral oil. It's not the group 4. We used the group 3, which is going to have a little more solvency. Plus we added in the seal material, seal conditioners to make sure that, then we also added a higher level of ZDP with a balanced detergent package to make sure we can protect a flat tappet camshaft. So knowing that the older style engines, those are the two main issues. Take care of the camshaft, take care of the seals, because synthetic oil by itself is actually a better lubricant than mineral-based oils. Yes. Every time. It can handle more temperature, which is why you saw the Valley tray on your dad's engine was so clean and all that. It's an absolutely better lubricant, but we have to make sure that we take care of the camshaft, and we have to make sure we take care of the seals. Well, those are additives that can do that. That technology exists.
Do you think that Mobil 1 back in the late 80s all the way through the 90s would have had the correct technology and additives to protect the camshaft? It never had drivability.
Oh, absolutely. Yeah. The camshaft issue with the additives in the oil really didn't come around until about 2001.
Okay.
2004 is when it really began to affect. That was API SM when that came out. That was the one that pushed the zinc levels lower to a maximum of 800 parts per million, where they could have been over 1,000 before that, or around 1,000 before that. That's where it really changed for everybody else. The race guys saw it a few years before that because we were running such aggressive camshafts when very high spring pressures. So the race guys saw it before the passenger car guys did. But yeah, I would say 80s through the 90s, yeah, piece of cake. There was plenty of ZDP. The detergent levels are pretty low enough that was not a problem. In fact, really, you probably make the argument that the OEMs, knowing how good the synthetics did in terms of cleaning the engines, that's what pushed the higher levels of detergent to make the regular oils keep the engines cleaner.
Yes.
Because once they knew you could make it cleaner, then that was what you have to do, right? That's the new standard now. So, yeah, synthetic by itself, in terms of lubrication properties, which what you were thinking, wasn't wrong for that engine, but most likely that older style engine. I've done a lot of antique car stuff in the past, helping engine builders with this same kind of problem. When you get into rope seals, that's where you really want a mineral-based oil that they're going to work best, especially the group 1s that have the higher paraffin content in them, that they're kind of waxy, which works really good with the ropes to make sure that things seal up. So also too, those engines back then, that was before they had multi-graded additives. You usually use straight grades back then.
Straight 30.
Straight 30. So I'm going to go out on a limb and say this car probably isn't going to drive a whole lot, and it doesn't need a whole lot of stuff. I would actually use the straight 30 break-in oil from Driven. Now, people who know me know that I used to work there and all that, so I know I'm being biased, but I also happen to know the chemistry. And and people that really follow my channel know application always dictates chemistry. I'm telling you to use this product, not because I get paid anything but from Driven to say it, or that somehow or another it makes me feel better to just recommend a product that I happen to know or have a be a part of. No, I have zero issues with that. It's about your application needs a straight grade oil made from a group 1 mineral based oil, and it really does need a higher level of ZDP with a lower level of detergent. Now, you could actually use, if they made one that was a straight 30 API SP oil, because the modern additive packages actually are fine with flat tappet engines. We actually proved that in the video recently on the Motor Oil Geek channel, where we took a 350 Chevy flat tappet, actually high lift, really aggressive design to wear out camshafts. We ran right off the shelf mineral based oil and synthetic oil. And the synthetic oil, Walmart, it was Walmart Super Tech, right? So we're not talking about high end, we're talking about Walmart Super Tech synthetic. And it did a better job protecting that flat tappet camshaft than the mineral based oil did.
Interesting. So on that topic, will all things considered, and I consider the seals, and now this is on an engine stand, so the time to change the seals and clean everything out was now, when I was being lazy, not taking the pan off when I was doing the work that I was doing to prove if it will run again. The question is, if I run that exact oil, that is the exact oils I use. I go to Walmart, I use that pretty much in everything, the lawnmower, the cars, except my wife's brand new vehicle. I ran Mobil 1 in that, but that's subject. Will I blow out the cam and all the hard parts in the engine by running it? The only risk being the seals.
Seals are the only issue, because the modern API SP oil has a lower level of calcium. Even though the zinc levels haven't changed, the calcium levels have come down significantly. So that calcium versus zinc competition we mentioned earlier, which was the key to the Joe Gibbs Racing thing, that's the key here. That the modern oils have other things like molybdenum in there, the moly, the 4-letter word you mentioned earlier. There's other additives in the oil. They provide better protection than the old oils do. The modern API SP oils are the best oils that have ever been produced. They're fantastic. All the wear testing, all the engine testing shows that they're better than all the previous generation products. In your situation, you just need to have the right type of base oil chemistry and viscosity to take care of that style engine. And that's where, if they're, wait, I got a better idea for you. Napa makes a straight 30 conventional API SP oil. That's the one to use.
Interesting. Okay. So I'm learning something. So in terms of the dispute, whether it's synthetics versus conventional, the wear rating on the conventional, the modern conventional. Now, I said that the Walmart synthetic oil was far better lubricant, superior to anything that engine ever ran from 1937 to 1969. That was my contention, and that by using that to get it started would not hurt the camshaft and the lifters and moving parts.
It will not. Now, is it the best option for that engine? No. Okay.
And I came into this with an open mind, knowing that you had the expertise on the subject to take in. I didn't want to, put up a wall and tell everyone, I'm doing this and that's it. There's some meaning behind having this conversation, and I thought your input is very well accepted. So Napa conventional with that rating, and it's
SP. Yeah, on the back of the bottle, there'll be that little donut. Yep. It should be straight 30, and it needs to have the SP donut on the back.
Yes.
And that'll be ideal for that engine.
I remember reading the labels on those. And when they came out with SJ, I believe that was J's my name. I thought that was my oil. So that,
yeah.
Side note.
SJ was pretty good oil back in the day.
Yeah.
Yeah. Well, the thing is, so this is what I like, Jay, about this is that this little discussion point is the perfect way of understanding this, right? Because you went after this from the mindset of chemistry. You thought chemistry first. Synthetic oil is chemically better than conventional oil. And you're 100% right. But without knowing it, you made the classic error that everyone makes. I made it myself. So I'm not saying that I'm some kind of super genius that always did get it right. I didn't know this myself. And I made that same error over and over again until I finally learned this.
I think you're a little bit more of a genius than you're leading on, but
no, I'm just saying, application dictates chemistry. That it's understanding what type of engine it is. What's it being used for? What are those bearing clearances? What are the valve train designs, right? In it. That will dictate what the correct chemistry is. There is no one size fits all best chemistry. It does not exist. When someone tells you they have some kind of magic molecule, some miracle oil that's going to work wonders for everything, run far, far away. It means they're either ignorant or they're trying to take your money.
Snake oil salesman.
Bingo.
So just so that we have it clear, I will admit that I was wrong in just assuming that running synthetic oil was the best option for that, just because of my history, knowledge of history,
sure,
my experience. I was going with the same playbook because it hasn't let me down. Now,
of course,
in terms of
probably haven't worked on very many 1930 engines before.
I've never worked on a 37 Oldsmobile engine.
Yeah. There's not many people that have, right?
Yeah.
And that's the thing. So if you had said this was a 1965 Oldsmobile, I'm going to say, oh no, put some Valvoline Restore and Protect in there. You're good to go.
Okay, that's a brand new oil too. Am I correct on that?
That's fantastic. I mean, the testing I've done so far, we have a video coming out probably in about 3 or 4 weeks. Following up with, I put it in my wife's van and run it. I mean, that oil is amazing at cleaning out stuff in older engines. So if you have a late 60s, 70s, 80s, 90s engine that, in the book, it says you can use a 530. Man, that stuff, because that's the thickest they have is a 530. I mean, it works fantastic, so especially for an older engine, maybe you don't know, you buy a new car, a used car, right? New to you. And you don't know the history on it. And you don't know how well it's been maintained. I mean, right now, based on the information that I have, that'd be my go-to to go in there and make sure it gets cleaned out, because it will literally clean the engine out.
Here's a fun fact on that topic that when I did the math on it, I was like kind of blown away. The equivalent of what we're doing with this 37 Oldsmobile engine right now is seeing if it proves to run. If we took an engine out of a 1993 Oldsmobile or Ford or whatever, took that out today, because I had a car that needed an engine, I put it in the garage, and then I never get to changing my engine, and it just sits there. We don't touch it, we don't maintain it, don't do anything, it just sits there in the corner of the garage. And then we revisit this topic and we take it out of the garage in the year 2079 and try to get it running again. That's essentially what we're doing with this. And when I did the math on it, I'm like, 55 years from now on a car that's, as old as that. So from, 37 to 69, and then that 55 years of sitting, I'll be dead by that time, 2079. I just thought that was kind of amazing, and it's kind of a fun project at this point.
Well, I think your biggest issue is going to be valve springs more than it is the oil. So
okay,
yeah,
you think they'll
more than likely that thing's not been rotated over, and
No.
valve train material today can handle being set. You could set an engine aside for 20 years and never turn it over today, and the valve springs will not lose any rate. They're not going to do anything crazy. They'll be just fine 20 years from now. That's not the case from the stuff back in the 30s. I'm taking a guess on this, but I'm going to say those older engines back then, the quality of the valve spring material probably wasn't as good as the stuff is now. More than likely, it'll have lost some valve spring rate, so it probably won't be able to handle much RPM.
Right.
That would be the thing. I'd be the biggest concern is about the valve springs breaking, not about what oil you put in there.
Okay. So,
because the thing is, if the seals leak, guess what? You can put more oil in there. Right. If the valve springs drop and fail, no,
you're kind of
out of a much bigger problem, right?
Looks like I'll be looking for valve springs for a 37 Oldsmobile engine. So, if you have them, hit me up.
Right, the guys at Eggy Machine out in California, they're the vintage stuff experts. I mean, it's EGGE.
Okay.
They've got new old stock of piston rings and pistons and all kinds of crazy stuff out there. So that'd be your best bet. Call those guys before you do anything else. For certain.
I will have to hit them up. Absolutely.
Yeah.
Absolutely. And now I know that you're pressed for time and we did go over. So I want to, if there's anything else that we missed on the topic before we say goodbye.
We hit the main points, right? Hopefully people take away the fact that, hey, the modern synthetic oils are the best oils ever produced in the history of humanity. So you should not be afraid of them. Even for flat tappet camshafts engines, they're perfectly fine. But API SP is fine for a flat tappet engine. You don't need to put additives in to make it okay.
All right.
If you have a much older engine like the one you're talking about, that's where, if you got rope seals and stuff like that, that's where you got to be careful about that. That would be the exception to that rule.
What's your feelings on semi-synthetic oils? We used a lot of that at the dealership when I was at Ford. That was kind of their mainstay.
Yeah. There's some back to application dictates chemistry. There are some valve train styles that perform really well, respond well to a synthetic blend, that the blend creates a different way the viscosity works under pressure. So when you have high pressure, like in a hydraulic valve train type application, sometimes the semi-synthetics can act thicker under high contact load, and it can actually be beneficial to the performance of the engine. So there isn't, like I said earlier, there isn't one size fits all best oil, best chemistry. Application always dictates chemistry. So you give the engine what it tells you it likes the best, which is why I'm such a big advocate of used oil analysis, because then you can operate from data, from facts, as opposed to speculation.
Yeah. Which I hate. So my biggest thing in the back of my mind, and maybe you can quell that notion, when I worked at Mack Volvo dealership, we had customers or fleet customers typically that would ask for oil samples because they would send that in because they would get an idea on their maintenance for an overhaul for their tractors that had close to 1 million miles or whatever their mileage interval that they were after. When you're talking parts per million, when I'd look at one of the data sheets, I would be like, 13 parts per million of copper or, whatever their spec was. How accurate did you think those are? I just found it really difficult with the concept that something couldn't skew those numbers way out of whack and you were, looking at something that really wasn't a problem.
Well, if one sample is like one point of data, it's like one pixel in a picture, not very clear. When you have multiple vehicles with all the same engine and you're taking multiple samples over time, then you create a very clear picture. You have lots of data points. So the more samples you take, the clearer the picture becomes the better your judgment is going to be. Put it this way. Every single military aircraft in the United States military gets oil samples taken every time it flies. Every time it flies. And it's go, no go, whether it goes back in the air again or not, based on that. Every commercial aviation plane also does used oil analysis. Every nuclear power plant, essentially everything really important in the world does used oil analysis.
And they
use that to make educated decisions. Us in the automotive industry are just decades behind.
Okay. And usually at least for the industries, the trucking industry follows the car industry. A lot of the technology that I learned at the dealership starting out was stuff that didn't come in till 10, 15 years later. Now you're running diesel trucks with 530 synthetic oil.
That's all fuel economy. That's right. All the low viscosity stuff's all fuel economy. That's us making the EPA happy. But the reality is used oil analysis is your tool to understand, okay, is this helping me or hurting me? Right? I know what the EPA wants. They want better fuel economy. And now if you're doing a big trucking fleet, you might be willing to give up a little bit of wear in order to gain more fuel economy because the cost of fuel is such a huge part of what they're doing. But at least they can make, again, educated decisions. You have data. You're not operating off speculation.
Do you have your own oil analysis lab at your house? Because I feel like you may be the guy that has that, or is there?
No, I mean, I have some tools here, but I don't do it from home. There's actually, I work with a lab up in Ohio that does a fantastic job that has all the right equipment. So we have customers that, use our service. We make it easy for people who don't have a background in it. Because when you go to a big fleet, right, they have somebody that has the same certifications that I do. They have a tribologist on staff that all they do is look at oil analysis reports every day for their fleets and make those kind of decisions. I act as that intermediary for our customers so that they don't have to understand, what PB is on a report, right? I can tell them that it's lead and it's from your bearings, right? Those are the kind of things that we do to make it easy for customers to be able to access the power of used oil analysis. And we can tell them something like, oh, okay, hey, for example, let's say you have a 2007 Porsche and your silicon levels are at 18 parts per million. Well, that's a problem for that engine. No one else is going to be able to tell you that, but I can tell you that because we know that those are alusil cylinders. They're not iron cylinders. They're aluminum silicon composite cylinders. So for that engine, 18 parts per million silicon is an early warning sign that the bores are beginning to scuff and score.
Ironically, I did work at a Porsche dealer for about 4 years. And the one thing that kind of amazed me, because this goes to fuel mileage too, and a lot of modern vehicles, we had Volvo there also, they use oil a lot more because they're going with the lower viscosity oil and the low tension oil rings because of the friction.
Yeah. Piston rings, the number one source of friction in the engine.
Yeah. So try to explain to a customer who laid down a lot of money for a 911 that you're gonna have to add a quart of oil every 1,000 miles because that's within Porsche.
That's normal, right? You better get used to having a quart or two in the boot always.
That's a tough sell. No doubt.
All right, man. I gotta go, but thanks for having me on. I really appreciate it. This has been a lot of fun.
I really appreciate you coming on, and anyone that is watching, please like and subscribe to his channel. I really appreciate your time. Thank you very much.
All right.
Talk to you sometime soon. All right. Take care.
All right. See ya.